Imagine standing at the edge of the most mysterious object in the universe, a place where gravity is so powerful, not even light can escape. This is a black hole. You're floating in space, far from Earth, staring into darkness. At first it looks like nothing, just an empty void. But look closer. Around it, space itself is bending. Light from distant stars curves and twists, forming a glowing ring around the darkness. This is called the event horizon, the point of no return. Cross it, and there is no coming back. As you begin to move closer, something strange happens. Time slows down. To an outside observer, you would appear to freeze at the edge forever. But for you, time feels normal. This is the power of extreme gravity. It stretches time itself. Now imagine you fall in. Slowly at first, then faster and faster. The pull becomes unstoppable. Your body begins to stretch, a process scientists call spaghettification. Gravity at your feet is stronger than at your head, pulling you apart into a long, thin shape. It sounds terrifying, and it is. But let's go even deeper. Inside the black hole, the rules of physics begin to break. Space and time swap roles. Moving forward in time becomes as unavoidable as moving toward the center. There is no direction left, except inward. What lies at the center? A singularity, a point of infinite density where all the mass of a collapsed star is crushed into almost nothing. The laws of physics as we know them simply stop working. We don't know what happens there. No one does. But here's something even more fascinating. From the outside, black holes aren't completely black. They can glow. As matter falls in, it heats up and forms a swirling disk, an accretion disk, shining brighter than entire galaxies. Jets of energy shoot out at near light speed, stretching across space for millions of kilometers. If you are liking this kind of video, do like, share, and subscribe. Now let's go even further, beyond what we can see. Some theories suggest that inside a black hole, space could be stretched infinitely, like a tunnel, a bridge. What scientists call a wormhole. Could it connect two distant points in the universe? Or even different universes entirely? We don't know. But the idea changes everything. There's also something called hawkingradiation. Over incredibly long periods of time, black holes can slowly lose energy and eventually evaporate. Yes, even something this powerful may not last forever, but the timescale, trillions of years, far beyond human imagination. Now imagine watching all of this from a safe distance. You would see stars bending, time slowing, and light itself struggling to escape. Black holes are not just destroyers. They are cosmic laboratories, revealing secrets about gravity, time, and the fabric of reality itself. And then comes the biggest question of all. What happens to information that falls inside? Is it lost forever, or somehow preserved? This question has puzzled scientists for decades and challenges the very laws of physics. And yet, despite everything we know, black holes remain one of the greatest mysteries in existence. We have captured their image, we have measured their effects, but what truly lies beyond the event horizon remains hidden forever. So the next time you look up at the night sky, remember, somewhere out there in the silent darkness, a black hole is waiting, a place where time bends, light disappears, and reality itself begins to break.